Hello everyone, welcome to our video presentation of a leveraging IT for a manager. Our topic is Amazon Web Service. There are four members in our group. The group number is HM319. Our team has worked together to dive into this subject from multiple angles to give you a comprehensive understanding of the topic. My name is Jinkle and I am starting the presentation from the slide 1 overview of Amazon Web Service. Let's start with an introduction to Amazon Web Service or AWS. AWS begins in its journey in 2006, fundamentally changing how business approach IT infrastructure. Before AWS, companies had to invest heavily in physical servers and data centers, which could take a months to procure and set up. AWS flipped that model on its head by offering on a demand cloud computing resources. Today, AWS is the largest cloud provider globally, offering over 200 fully featured services like computing power, storage, database, and even AI tools. What's amazing about AWS is that flexibility. From a small startup to tech giants like a Netflix, companies of all sizes rely on AWS to scale their operations. AWS also support industry ranging from a healthcare and a finance to government agency, showing just how broad its impact has been. Let's take an example. Take a Airbnb for example. In its early days, Airbnb leveraged AWS to handle sudden bursts of a traffic without worrying about server capacity. They could scale up during a peak travel time and scale down during off seasons, paying only for what they used. This ability to scale and innovate quickly helped them grow into a global companies they are today. The next slide is global infrastructure and availability zones. AWS global infrastructure is one of its most defining features. AWS operates in multiple regions across the global, and within each region there are several availability zones or AZS. These AZS are essentially clusters of data centers that are isolated from each other to prevent failure in one zone from affecting another. If one data center goes down due to a power failure or a natural disaster, the other AZs can pick up the load. This is multiple AZ architecture is what make AWS highly reliable, offering 99.99% uptime of its services. Whether you are hosting a website, running database, or a processing machine learning models, you can trust AWS as infrastructure to keep your service available globally. For example, Netflix, which streams content to millions of users worldwide, uses AWS global infrastructure to ensure that viewers can access their favorite show and movies with minimal interpretations. No matter where they are, if there are an issue in one region, Netflix can switch to another region seamlessly without a user noticing. The next slide is scalability and elasticity in AWS. One of the AWS strongest feature is its scalability and elasticity. Scalability refers to AWS ability to grow with your business. Whether you need one server or 1,000, AWS can accommodate your need in a real time. Elasticity, on the other hand, means that AWS automatically adjusts the resources of your using based on the current demand. If your website suddenly gets a surge of a traffic, AWS will automatically scale your resources up to handle it. Then, when the traffic dies down, AWS scales those resources back down, so you are not paying for unused capacity. Example, a great example of a AWS elasticity is a Black Friday sale. E-commerce site like Amazon.com see a huge spike in traffic during a holiday shopping events. Instead of buying and managing extra servers to prepare for this company uses AWS elasticity infrastructure to scale up during this sales event and scale down when traffic normalizes, saving them both time and money. The next slide is Amazon EC2, the power of a cloud computing. Amazon EC2 or a Elastic Compute Cloud is one of the AWS most popular service. EC2 allows business to run virtual service and in the cloud, giving them the flexibility to choose their operating system, memory, CPU power, and even geographical location of the server. What makes EC2 special is that you can launch an instant in a minute and scale it up or down based on your workload. EC2 can be used for anything from hosting website and apps to running large-scale enterprise application. Let's take an example. Think about a company like Adobe, which uses ACT to provide a creative tools to users across the globe through their Creativity Cloud site. Adobe does not need to maintain physical servers for millions of users. They rely on EC2 to deliver the software on a demand, whether users are in the New York, Tokyo, or Paris. The next slide is Amazon S3 Scalable Storage Solutions. Amazon S3 or a simple storage service in a AWS flagship storage solution. S3 is designed to store and retrieve vast amounts of data. Whether you need to store media files or backup database or archive old logos, S3 can handle it. One of the key features of a S3 is tiered storage options. For frequently accessed data, you can use S3 standard, but if you have a data that you relay access like a long-term archives, you can store it in a S3 Glacier, which is much cheaper. S3 also offers 99.999% durability. Yes, that's 11.9. This means your data is practically guaranteed to be a safe. Let's take an example. Take a Dropbox. It's originally built its infrastructure on a AWS S3. By using S3, Dropbox could store billions of files for a millions of users while ensuring a high availability and security. Even as a Dropbox has built its own infrastructure, it still relies heavily on S3 to provide scalable storage solutions.
My name is Krupa Chaudhary and now I am continuing with this slide. AWS Lambda Serverless Computing. With AWS Lambda, AWS introduced the concept of serverless computing. In a traditional setup, you have to manage the servers where your code runs. But with Lambda, AWS takes care of that for you. You simply upload your code and Lambda runs it in response to events, whether that's a file upload, an API request or something else. The real magic of Lambda is that it scales automatically. If your code needs to run once or a million times in a minute, Lambda handles it without you having to intervene. Example, for instance, Coca-Cola uses Lambda to power its vending machine service. When a customer makes a purchase, Lambda is triggered to update inventory, process payments, and send receipt, all without Coca-Cola having to manage any servers. It's a great example of how serverless can simplify infrastructure management. Next slide, AWS pay-as-you-go pricing model. The pay-as-you-go pricing model is one of AWS' biggest advantages. Unlike traditional IT setups where you had to pay upfront for expensive hardware, with AWS you only pay for what you use. If you need to run a server for just a few hours, you are billed only for that time, and as your usage grows, you pay proportionally. This model makes it easier for startups to get started with minimal capital and scale their cost as their businesses grows. Plus, AWS offers various pricing options like reserved instance, which can save businesses up to 70% if they commit to long-term usage. Example, startups like Airbnb and LYFT benefited immensely from this pricing model. In their early days, they didn't have to invest in expensive hardware to support their growing user bases. Instead, they could scale up incrementally, uses AWS, and only pay for what they needed and the time. Next slide, security architecture in AWS. Security is always a top concern in cloud computing, and AWS has built a robust security architecture to address this. AWS uses a multi-layered approach to security, starting with physical security. AWS data centers and heavily guarded, monitored, and even earthquake resistance. At the network level, AWS provides firewalls, DDoS protection, and instruction detection. AWS also offers encryption both in transit and at rest. So whether your data is traveling between servers or sitting in S3, it's encrypted. Example, let's look at the healthcare provider that's using AWS. HIPAA requires stringent data protection for patient records, and AWS helps ensure compliance by offering encryption, logging, and access controls. This allows healthcare companies to store and process sensitive data while meeting regulatory requirements. Next slide, AWS and discrete event simulation. Discrete event simulation is a crucial tool for industries like manufacturing, logistics, and even gaming, where businesses need to simulate complex operations. AWS enables this simulation to run at massive scale. By using services like EC2 and Lambda, companies can simulate thousands of events simultaneously and get results in real time. This helps businesses optimize processes, reduce cost, and make better decisions. Example, for instance, a logistic companies might simulate different shipping routes using AWS to determine the most cost-effective option. By running these simulations on AWS, they can process more data in less time, ultimately improving their operational efficiency. Next slide, data inscription and IAM in AWS. Data inscription and identity and access management are two crucial elements of AWS security strategy. AWS provides several inscription options, including server-side inscription for data at rest and client-side inscription for data in transit. AWS Key Management Services helps manage your inscription keys securely. On the access side, IAM allows you to define who can access which resources. With IAM, you can create policies that limit access based on the user's role, ensuring that only authorized individuals can access sensitive data. Example, take a financial institution using AWS. They can use KMS to encrypt customer data stored in S3 and use IAM policies to ensure that only specific employees adds multiple layers of protection even with the organization.
Myself, Drashtiben Chaudhary, and I will continue with this presentation. My topic is AWS for High Performance Computing (HPC). AWS is a powerful tool for high performance computing or HPC, which is needed for tasks like weather forecasting, molecular simulation, and financial risk modeling. AWS offer specialized EC2 instance optimized for HPC with enhanced networking and GPU capabilities. AWS also make it easy to create large cluster of machine to run complex computations, allowing companies to process vast amount of data quickly and cost effectively. For example, the National Aeronautics and Space Administration NASA use AWS for processing satellite data to model climate patterns. By leveraging AWS HPC capabilities, NASA can run simulation faster and more efficiently than using their traditional on-premise infrastructure. Next is scaling HPC workloads on AWS. AWS provides a robust infrastructure for scaling HPC workload, offering features like enhanced networking with up to 100 Gbps throughput for a fast data transfer between EC2 instances. FSX for a Lustre, a high-speed parallel file system, is optimized for data-intensive HPC applications, enabling efficient storage and retrieval of large datasets. AWS Parallel Cluster simplify the development of HPC environments, allowing users to quickly scale up or down based on workload demands. The flexibility of scaling across multiple instances significantly reduced the time required to process complex simulations, helping industry accelerated research and innovation. For example, a climate research institute used AWS to run complex weather models, reducing computations time, enabling more accurate forecasting and improving disaster preparedness. AWS ability to handle large-scale data processing enhanced their research efficiency. Next one is AWS for biomedical cloud computing. In healthcare and life science, AWS offers scalable and secure solutions for biomedical cloud computing. With AWS, research teams can quickly process large data sets for genomic sequencing, drugs discovery, and patients' data analysis. Services like AWS Elastic Beanstalk, EC2, and S3 are commonly used for computational biology workloads, allowing healthcare organizations to innovate faster without having to invest in expensive hardware. For instance, companies like Moderna used AWS to accelerate COVID-19 vaccine development. AWS simulate vaccine responses and share results with global research team in real time. This dramatically shorten the development timeline. Next one is challenges and solution in AWS security. While AWS offers strong security features, managing security in the cloud does come with its challenges. Misconfigurations such as leaving S3 buckets open to the public or not securing API keys are common issues that lead to security breaches. AWS provide tools like AWS Config and AWS Trust Advisor to help identify misconfigurations. But it's still up to the users to ensure their environment is secure. Another challenge is managing user access. AWS IAM is powerful, but if policies are not correctly implemented, it can lead to the authorized access. For example, in 2017, a misconfigured S3 bucket resulted in the exposure of personal information from a large credit reporting agency's. AWS wasn't at a fault. It was the responsibility of the company to secure its S3 bucket properly. This underscores the importance of property configuring and managing cloud services. Next one is the shared responsibility model in AWS. The AWS shared responsibility model key to understanding cloud security. AWS takes care of the security of the cloud, meaning the infrastructure, hardware and software running AWS services. On the other hand, customers are responsible for security in the cloud. This includes things like configuring firewalls, managing user access, and securing data. AWS provides many tools and services to help customers with their responsibilities, but at the end of the day, the customer controls their own data and applications. For instance, a retail company using AWS must ensure that its database is encrypted, access control are in place, and that data backup are happening as needed. AWS meanwhile ensure that the physical data center hosting these companies' applications are secure and running smoothly.
My name is Bhumika Bin Kathiria and I will explain for the slide that is HEP Cloud Project and AWS. The HEP Cloud Project, short for High Energy Physics Cloud, is a great example of how AWS is being used in cutting edge scientific research. This project enables researchers working on high energy physics, like those studying particle collisions at CERN, to process massive data sets quickly. AWS provides the computational power needs to stimulate and analyze these experiments in real time. By leveraging the scalability and on-demand nature of AWS, the HEP Cloud project has transformed how high-energy physics data is processed and shared. For example, AWS helped formulate process data from the large hardened corridor more efficiently, reducing the time took to analyze data by scaling up compute resources during peak times and scaling down when not in use. Next is cost optimization strategies in AWS. One of the biggest advantages of AWS is the potential for cost savings. But to fully realize those savings, businesses need to optimize how they use AWS services. One strategy is using reserved instances for predictable workloads, which can save up to 75% compared to on demand pricing. For unpredictable workloads, using spot instances can help reduce costs, as these instances use spare capacity in AWS data centers at a lower price. Auto scaling is another key feature that helps optimize cost by automatically adjusting your compute resources to meet demand. And of course, AWS Cost Explorer and AWS budgets provide visibility into spending, helping business identify areas where they can cut cost. As example, take a media company using AWS to host video content. By analyzing its uses patterns, it might decide to purchase reserved instances for its base workloads while using spot instances for extra capacity during a peak streaming times, significantly reducing costs. Next is AWS in geoprocessing and GIS applications. Geoprocessing and GIS, Geographic Information System applications, involve analyzing spatial data, which can be highly computational and storage intensive. AWS provides tools like EC2, S3, and Lambda to help businesses process large geospatial datasets quickly and at scale. AWS even has specialized tools like AWS Ground Station, which allows the businesses to process data from satellites by using AWS scalable infrastructure. Companies can run a geospatial analysis in real time, helping them make faster, more informed decisions. For example, Esri, a global leader in GIS software, uses AWS to deliver mapping and analytics tools to its customers. AWS enables Esri to provide high performance geospatial services that can handle large data sets and deliver real time insights to users in industries like agriculture, urban planning, and disaster response. Next is service-oriented architecture on AWS. AWS supports service-oriented architecture, which allows businesses to build applications composed of small independent services that communicate with each other. SOA is a great fit for AWS because AWS provides a range of services that can be easily integrated, from EC2 for compute to RDS for databases and SQS for messaging. By using SOA, businesses and build modular applications that are easier to manage and scale. For example, Amazon.com itself is a prime example of SOA in action. Every feature you use in the site search recommendations checkout is powered by individual services running on AWS. This modular architecture allows Amazon to develop and deploy features faster while scaling seamlessly to handle billions of transactions. Next is AWS Managed Services boosting productivity. AWS Managed Services allow business to offload many day-to-day operational tasks such as patch management, backups, and monitoring. Services like Amazon RDS, which manages databases, and Amazon Elasticsearch service for search and analytics, help boost productivity by taking care of the heavy lifting. These services automatically handle things like backups, updates, and security patches. This allows developers and IT teams to focus on building new features or improving performance instead of spending time managing infrastructure. For example, let's say a fintech company is using RDS to run its financial databases instead of spending time managing updates, backups, and security. The IT team can focus on enhancing their app, delivering new features to customers faster, and improving overall productivity. And in the conclusion, AWS has completely transformed how businesses and organizations approach IT infrastructure by providing a diverse set of scalable, secure, and cost effective services. From Amazon EC2's cloud computing capacity to AWS Lambda serviceless capabilities, and from safe data storage in Amazon S3 to strong high performance computing for industries such as healthcare and scientific research. AWS delivers the tools needed to innovate and flourish. AWS caters to startups and large companies alike with its worldwide infrastructure as you go pricing and comprehensive security features. It's crucial to note that while AWS provides amazing flexibility and capability, it also follows a shared responsibility approach. And as the organizations utilize AWS, they must be attentive about correct configuration, security, and optimization.